So, probability, kids either love it or hate it. Hopefully you love it. Good talk. So, some of these warm-up problems you might not love a whole lot, but they're going to help us later on with some of the other problems. So just hang in there. So for instance, we're going to see this again. Okay, so this is why I'm doing this in your warm-up problem. In an experiment, 3 coins are flipped, and I just kind of gave you a little picture of what that could look like. List the possible outcomes in the sample space. So we're going to have to be listing some sample spaces today to help us calculate probability. So when I look at that outcome, I'm just going to list it as heads, tails, so HHT. Now, clearly, that's not the only possible outcome we have if you flip 3 coins. What other possible outcomes could you have? Hannah, give me one.
All 3 heads.
All 3 heads. Clearly, there's more. What else could you have?
Tails.
All 3 tails. Now, one thing, too, that might kind of help you, this is me. I'd like to know how many are there before I start listing them. So just to review on 8-5, there's 2 outcomes for this coin, heads or tails, 2 outcomes for this coin, and 2 for this one. And remember, we multiply them together. Well, what's 2 times 2 times 2? 8. Clearly, I need some more. Okay, there should be 8 total. I've only got 3 listed. What are some other possibilities? Heads, tails, I think I heard. Heads. What else? Heads, tails, heads, I think I heard. What else you got? Tails. Tails, heads. From Grant. What else you got? Tail, head, tail. 1, 2, 3, 4, 5, 6, 7. What's the last one? So we're going to use these again in another problem because eventually what we're leading you up to, and this is so easy, once you have the outcomes, now if I asked you, what is the probability that all 3 coins are tails? Well, how many outcomes are there that all 3 are tails? 1 out of 8. That's your probability, which we're going to get to that. Okay, write small. Here we go. Let's first figure out how many total we should have. Now, on a dice, you have the numbers 1, 2, 3, 4, 5, 6. So there's 6 outcomes for each die. What's 6 times 6?
36.
And we have to list all 36. Now, don't cringe, just wait. Because there's 2 problems in the notes that we can reference back then once we have it listed. There's a couple problems on the homework too. You will not have to relist these 36 outcomes. We're just going to use them then for the remaining problems. So let's get them listed here. Now, I like to work organized. So I could roll, let's say, a 1 and a 1, a 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6. So there's 6 outcomes. I could do a 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6. 12 outcomes. You get the pattern. 3 and a 1, 3 and a 2, 3 and a 3, 3 and a 4. Okay, all right, we're halfway, halfway. Make sure we're getting these all written down and make sure our phones are away, please.
Good reminder.
This is why I said write small, because we need all 36, of course. I'm still going. And of course, I need 6 final outcomes, and that would be if we start with 6. Okay, so like I said, there's going to be some problems that ask us of using these 36 outcomes coming up in the notes. There's also going to be some in the homework. Thank you. You do not have to rewrite them out. Just flip back to your notes, count what it is you need to count that they're asking about, and move on with your life. Okay, some vocabulary that we are going to need today. So probability and experiment. An action or trial, so like flipping the coins, that you get varying results. So just like I said, if you flip the coin, it gets a heads or tails, varying results, okay? The outcomes, the results of a probability experiment. Now, to me, outcomes and sample space are very, very similar to me, okay? So I am gonna do 3, but I'm gonna go to 4 here next. So what is the sample space? That's what we just listed. The set of all possible outcomes. Okay, so here's the difference, and this is negligible, and I'm not going to be upset about this whatsoever. So outcomes, it says the results. Sample space says it's the set of all the results. Okay. So for instance, what I have listed here is the results. This is the outcomes. Ready for this? This is how you make it a set. You put curly braces around it and put commas in between it. Does it matter? No. Okay. So I'm not going to be upset if it asks you for sample space or something and you don't have the curly braces and the commas. Just have everything listed. But to me, those are kind of synonymous. All right, event, the collection of one or more events. So you roll a die and, I don't know, you toss a coin. So you write them all out, all the different possibilities. It all boils down to the same thing. You're writing out, like we just did, all of the possibilities. If it asks you for sample space, I should have braces and a set around it, but I just care that we have them all, because that's what we're going to need today. All right, so determine the sample space. So if I'm going to get fancy here, sample space, it should be a set. Do I care if you put the braces on? No, I don't care. But what are your outcomes if you roll a 6-sided die? One of them. What are your outcomes? 1, 2, 3, 4, 5, 6. And again, I am not going to mark off if you don't have the braces around it and it's a set. I care that you have the 1, 2, 3, 4, 5, 6. All right, 2 county supervisors, I'll put this that, are chosen from those to study a recycling thing. Okay, now, 2 of them. So I'm going to pair them up together, like I could have A and B. Now, here's a question for you. Do I need to put B and A? No, aren't they the same 2 supervisors? Yeah, so we're just looking at how we can order these or put these together. So I could have A and C, we could have A and D, A and E, and then of course that covers all the A's. So let's look at the B's. I've got B and A, let's do B and C. I don't have B and D, and of course I don't have B and E. So that kind of covers all of those. So I'm looking at C. I got CA, I got CD, so let's do CD, CE. And really there's one last one. What is it? D. And again, I don't care if you have the braces around it and it's a set or not. Okay, that's as wild as that gets. Now, probability. Let's talk about how do you actually calculate it and what style you can give your answers. So, probability, of course, the likelihood an event can happen. So the probability it's going to rain today, I don't know, 30% chance. So you can, of course, give your answers decimal fraction percent. I don't care how you give them. I kind of mixed and matched today, just do a little bit of everything. 0%, of course, it's not happening. 100%, of course, it is happening, okay? So easy enough. Flip the page. I couldn't fit all yours on your OneNote page there. So flip it to fill these in. So what we're going to use today, really, are these 2 at the bottom. So favorable outcomes. The outcomes for a specified event. So meaning, when we did the 3 coins toss, I said, what's the probability all 3 are tails? That was your favorable outcome. That was your specified event, all 3 tails. And then you have to fill this in. To calculate the probability, it's those favorable outcomes over the total. So let me give you a minute to write that in, and I'll start doing some probabilities. Now, I tend to give my answers fraction style, just because your calculation is a fraction. But you'll see there's some other problems today where they give you the numbers as percentages, so I'll give my answers percentages. I don't care again of what style you give your answers. Now, I'm a little off the screen here for all of them, but these are the same 8, let me click it back, that we just listed here. I just listed it so they're in front of you too in your notes here. Okay, probability of getting one head on the first toss. Well, clearly there's 8 total outcomes, so I'm going to fill that in. Just go through and count the list. Look at yours because I'm off the screen there. What's the probability one head on the first toss? So your favorable outcomes, how many are there? 4, because heads on the first toss, like that, there's one behind it, I'm off the screen. Heads on the first toss, and I'm going to reduce it. This is what you're doing today. All right, now it's 8. Now at least 2 heads, 2 or more. How many favorable outcomes are there? Remember, look at yours, not mine, because one's off my screen. There are 4. Very exciting stuff. Now, don't forget too, on these next card problems, if you do not love cards, I did put a picture, like I told you I would, of a deck of cards on Google Classroom. You can just pull this up and straight count it. You will be provided this picture too, but I find that kind of obnoxious for me to just have to go through and count them. So let's see what we can do here. So find the probability, one standard from 52. Okay. So question is, how many cards are black in a deck of cards?
No, 26.
26, because there's 13 spades and 13 clubs, so 26. Now again, if you're like, oh my gosh, I hate the deck of cards, I don't know a spade from a club, look at the picture and you could manually count that there's 26. Or really, isn't half the deck black and half the deck red? Card is a numbered card. I'm going to put the 52 in. 2 through 10. So I could pull up the picture, numbered card, 2 through 10, and start counting. I don't know if I really want to count them all. Or let's do this. 2 through 10. How many cards are there? 2, 3, 4, 5, 6, 7, 8, 9, 10. How many are there? 9. And there's how many of each? 4, because they each have, there's 4 suits: clubs, diamonds, hearts, spades. So of course, 9 times 4. Or like I said, you could pull up the picture and count all of these and do it that way. I find that obnoxious. I reduced that earlier. It's 9 over 13. So any questions on the cards? Okay, here's going to be where we need that warm-up problem. Probability tossing a 6-sided die twice. That's why we wrote those all out, because I'm just going to click it back and count them off of that. Now I know there's a total of 36. We already wrote out all 36. Sum, add, at least 8 or more. Okay, let's look at them. So if I look at all 36, I'm just going to start circling them. If I add them together, I want 8 or higher. So meaning 1 and 1, if I add it 2, that's not 8 or more. 3, 4, 5, 6, 7. Nothing in this one. Oh, come on. Back to it. If I start adding these, 3, 4, 5, 6, 7, oh, 8. I'm going to circle, there's a favorable outcome. If I add these, 4, 5, 6, 7, 8, 9. Says at least 8. Okay, I'm still adding. 5, 6, 7, 8. That would be 9. Got it. 6, 7, 8, 9, 10, 11. Okay, what are your favorable outcomes in the last column? What am I circling? How about that? Okay, count them. How many favorable outcomes do you have? I'm going to give you a minute to count. 15, so we're going to put 15 out of 36. Let me click it forward. And of course, we're going to reduce that. It reduces down to 5/12. So it's going to be similar types of questions on your homework. Just use those 36, don't redo them. Okay, oh boy, sum is odd or prime. Okay, odd or prime. I'm going to circle these in purple. If I add 1 and 1, I get 2. Is that odd or prime?
Yes.
It's prime, right? 1 plus 2. Yeah, that's odd. 4, 5, 6, 7. Okay. 3, yep, 4, nope. 5, 6, 7, 8, no. 4, nope. 5, 6, 7, 8, 9. 9's odd, of course. 5, 6, 7, 8, 9. 6, 7, 8, 9, 11. Okay, odd or prime we're looking for. Remember, 7, odd. 8, nope. 9, nope. 11, got it. Count them. What do you got for a total?
19.
19. So I'm going to put 19 out of 36. Whew. So much fun. Okay. Okay. So like I said, the same. There's similar questions asking you different stuff, but out of the 36, just flip open your notes and count them off of there. Let's do some marbles. So find the probability of drawing 2 marbles without replacement from a bag containing 1 green, 2 yellow, 3 red. First question, how many total marbles are there? 6. Now, here's the thing. After we've written out those 36 and all of that, I don't know if I have it in me to write out the first red marble with the second yellow marble, the green marble with the third red. I don't feel like writing those out. I don't. So let's just kind of work smarter here, just off the side here to get our total. Let's use some knowledge from our last section. Now, does the order I draw the marbles out matter? Nope, so I'm going to go combination. There's 6 total marbles. We're selecting how many at a time, does it say? I punched this in my calculator earlier. For those that were gone on Friday, remember it's under your math menu probability. You can see I can't remember the answer, it's 15. Okay, all right, got it. So there's my total. Now, because I didn't actually, we're tired, we don't want to write out all 15, I'm going to do the same thing for the top. I'm going to use a combination. How many total yellow marbles are there to select from? 2. And we want both of them to be yellow. So the 2 we pick want to be yellow. So I punched that in my calculator earlier, and I got 1. So 1 out of 15. Got it. So same type of thing here. I'm going to go ahead and put the 15 in. Now, different colors. Okay, so here we go. Different colors. So meaning you could have like a green and a yellow. We could have those together, or yellow and green, it doesn't matter, same deal. Green and red. And of course we could have yellow and red. So I'm looking at scrambling up the colors. So I'm going to do the same thing. I'm going to write some combinations for them. I'm going to start with the green and the yellow. So how many total green marbles are there to select from? 1, and we want 1 green. Now yellow. How many yellow marbles are there to select from? 2. And we know, of course, we're going to multiply these together. Okay, I'm going to do, just to kind of mix it up, these, I'm going to write that one in red. So green, of course, we already did that combination. Notice I intentionally left some space, leave just a little bit of space there. And then red, of course, how many red marbles are there to select from? 3, and we're going to have one of those guys. I'm going to do this one in purple. Leave just a tiny space there. Okay, now yellow. We already did yellow, of course. Yellow, there's 2 yellow to pick from. We're going to have 1. How many red are there to pick from? We're going to have 1. So to do the top, we're going to total up all of those combinations. So I punched that in my calculator earlier. I'm not going to bore you typing it in now. I'm just going to tell you what it is. The numerator is 11, so 11 out of 15. Just if we didn't want to have to write out all 15 and count again. All right, next thing is super easy. Ready? If the chance of rain is 30% today, what's the chance it won't rain? 70. Okay, that's what we're going to talk about. That is the complement of an event. So the chance that will rain 30, you got the 70% because they total up to 100%. Or of course 1 if we're not in percent style. So flip it. So if you know the probability of the event that it won't happen, of course you're just going to subtract it. So just like how you did 100% minus the 30% I gave you, that's all you're going to do is subtract it. And just some notation, if you see that little symbol, that means the complement. That's what they're asking you to calculate, and you read it as a bar. So just if it says to find that, you have to recognize they're asking for the complement. So probability that it will happen. What's the probability it will not happen? If it's 0.36, what's the probability it won't happen? 0.64. Now I just care about the 0.64, but just for notation, just to be fancy here, you might see this written like this with the bar. That means the complement. I care that you got the 0.64. All right, what is your probability of the complement? If it's 70 will happen, it's how much it will not. Okay. Got it. All right, I think we've done enough on that. Okay, now we're to those formulas on your yellow sheet. So just if you want to reference. On the back side, those last three formulas are what we're going to take a look at now. Probability of independent events. Let's start with that. So independent events, the occurrence, sorry for my sloppy handwriting, this is a U, of one event does not affect the occurrence of the other. So meaning, if I roll a die and then I flip a coin, they don't affect each other, okay? They're independent events. So to find those probabilities of the two combined together, key word here is and. Probability I roll the die and it hits whatever, and I toss the coin and it lands on whatever. You just multiply your probabilities together. Now, other key words here that might help you. It might not actually have, say, the word and in there, but it's implied. They might say both. So this one and the other one. Or maybe all. There could be three events, all three of them. You are going to multiply together. So those are kind of some key words. And I'm like, okay, if I see all, both, and, I'm going to multiply them together. Because, of course, it's going to switch on you. If you see or, probability of A or B. So you're going to do the probability of the first event. But if it says or, you have to add. So that's what I was doing on those marbles. What's the probability of a green and a yellow, or a red and a green, or whatever? That's why I added those together. Now, here's the one tricky part of this, and I'm going to show you this. You could potentially, especially on card problems, deck of cards, what we say double count, have events in here and here that are the same. So you have to subtract off this. And you're like, what in the world? So we can't double count. And I'm going to show you this. Don't let it scare you. I promise you it's easy. And that's going to be the next example. Now, of course, if they don't have anything in common, there's no overlap. You don't have to worry about it. You can just straight add them. You don't have to worry about the double counting. So when you see the word or, it has to signal to you I'm adding, and I got to be careful about double counting. And who cares? You just multiply them and it doesn't matter. So here we go. One card selected at random from 52. The probability of the card is a face card or a black card. Now mine's kind of ran off the screen together. Yours looks a little nicer. So first off, total cards on a deck. I know the word or means we're going to add these two together. Now let's start with face cards. How many face cards are in a deck? 12. Because you jack, king, queen, there's 4 of each. How many black cards are in a deck? 26, half the deck. Now before I add these, we got a glitch. I double counted. aren't there face cards that are also in the black cards? I double counted. So I have to take off how much I double counted. How many did I double count? 6. And I'm just going to put, that's my little note. Okay, so I totaled all of that up. I reduced it, blah, blah, blah. You get 8 out of 13. Now again, if you're like, oh my God, these card problems, I hate these. These are the worst. Face card or black card. Pull up the picture and just straight count how many are face cards, how many are black cards, and just do it that way if you have to. But hopefully we can just do it off the fractions. Okay, the card is a heart or spade. So I know I'm adding again. So how many hearts in a deck of cards? 13. How many spades in a deck of cards? Is there any double counting here that could happen? No, there's no hearts that are both spades. That's weird, okay? So I'm just going to straight add 26 out of 52, half the deck. So this is the only tricky thing on probability, is only happens when it's or, and you have to watch the double counting. Other than that, it's super straightforward and easy. It's the only trick of the day. All right, let's do some more. Random number generators, 3 numbers, 1 through 10. Find the probability of the event. All 3 are a factor of 8. Well, first off, let's talk total. 1 through 10, there's 10 numbers. Okay. Let's talk about our favorable outcomes, factor of 8. So that means they divide into 8 evenly. Like off that list of 1 through 10, I know 1 goes into 8. I know 2 goes into 8. What else goes into 8? 4 and 8. So there's 1, 2, 3, 4 favorable outcomes. Now that's not my final answer. Hang on here. All 3 numbers. So we're going to have 3 probabilities. 3, 4 out of 10. Because they all have the same. Now here's the big question. Am I adding or multiplying these? Multiplying, or, and, both, all of them together. So I multiplied it, reduced it. I'm not going to bore you with that. You get 8 out of 125. Okay, still 3 numbers, so still 3 fractions. I know it's out of 10. Okay, let's talk favorable outcomes. How many favorable outcomes are there in 1 through 10 that are greater than or equal to 9? How many favorable outcomes do you have? 2. 9 and 10. And then, of course, the question of the day, am I adding or multiplying those probabilities together? Multiplying. Keyword all. I punched it in, reduced it earlier, blah, blah, blah. You get 1 out of 125. Any questions on that? Home stretch, my friends. Home stretch. Okay. Ready? So wordy, so many words here. Okay, in 2004, there's approximately 8.15 million unemployed workers. Gosh, that seems like a lot. Circle graph shows the age profile of the unemployed workers. You can see the circle graph. A, estimate the number of workers. Now, I'm not asking for a probability. I want how many workers. Okay, all right, we can do it. So look over there. Give me the percent first. How many workers are in that 16 to 19 category? So 15% of the 8.15 million are unemployed. I'm going to abbreviate that. Now, I want to actually calculate that. I want a numerical answer for it. I don't have a percent key on my graphing calculator, so I'm going to put this as 0.15. What's of mean in math? Multiply, just multiplied it together. So punch that in. What's 0.15 times 8.15? Round to whatever, I don't care. 1.2. And I'm just going to label that's in millions. So just notice they got fancy and you actually are not giving a probability there. You're telling how many workers. Okay, let's read B. Oh, probability. Okay, selected at random, blah, blah, blah. 45 to 64. Okay, look at the chart. How many are in the 45 to 64? Now, is percentage a probability? So we're done. Probability, the workers are 45 or older. What's your percent? 26, 45 or older, so it's these two combined, 26. Now, if you wanted to give those as fractions, it'd be 26 over 100, and you could simplify. But I don't care. Gave percents, make it easy. All right, more cards. Here we go. Okay, sample spaces are large, so I'm going to use, like it says, I'm counting because I'm like, why are these sample? Oh, 108 cards. Yeah, that's a lot of combinations I could write out. I'm not doing it. So I'm going to use, of course, combinations. So deck of cards, 108 cards, 25 red, 25 yellow, 25 blue, 25 green, and 8 wild cards. Okay, let's do the easy part, I think, first, the total. Now, I started with combination, of course, because the order you have the cards in your hand doesn't matter. I mean, I like them organized, but they don't have to be. There's a total of 108 cards, and they want you to have how many in your hot little hand? 7. So we'll figure that in a sec. Now, we're doing the probability 2 wild cards. Okay. Well, how many total wild cards are there to select from? 8. And they want you to have 2. Now, hang on a minute. That's only wild cards. If I have 2 wild cards, that means, because I have 7 in my hand, that means the other 5 are out of that red, yellow, blue, green. Because we have 7 total in the hand. Now, my question for you is, how many total red, yellow, blue, and green are there? If you have 25 of each, there's a total of 100. And then, of course, our question is, do we add or multiply these? Well, yeah, you have 2 wild cards and all the different colored cards, the red, yellow, blue, green. And so you're going to multiply it. Okay, I punched it in earlier. You don't have to. And I gave this one as a decimal just because I haven't given any decimals yet. I don't care what style you get it. All right, we're going to do kind of the same thing. I already got the total over here. Let's fill that in. And 2 wild cards. I mean, I already wrote the combination for that over there. I'm just going to steal it. Okay, 2 red cards. Red. How many total red cards are there to select from? 25, and they want you to have 2. And then blue cards. They want you to have 3 blue. Well, how many blue are there to select from? 25. And remember, and. So we're going to multiply. I punched it in. This one kicks you into scientific notation. It pops the E into it. So I just rounded it. 6.9 times 10, -4. Got it. All right, final problem. Are we ready? Probably were ready about 25 minutes ago, I guess. So. Okay. Space vehicle has an independent backup system, blah, blah, blah. Probability that the system will function satisfactorily is this. So I'm going to keep that number in the back of my head. So I'm looking at that like, okay, 98.5%. That's pretty good. I like it, okay? All right, carry on. What's the probability that during a flight, both systems function satisfactorily? Let's start with A, of course. Both. So I hear the word both, and I'm like, and, all. So I know I'm going to multiply these together. So the probability that they both function satisfactorily. Well, that probability is that 0.985. We're going to multiply that together. So I punched that in earlier. We get 0.9702. Okay, B. At least one system functions satisfactorily. Sorry. So you have one function, at least one, or maybe none. And I'm going to show you a work smarter, not harder way on that. So I'm reading this and I'm like, well, at least one, so one or more, or I'm going to have to add, oh, that already seems like work. I'm going to use C to help me. If I can stop coughing. both systems fail. Well, if they have a 0.985% chance of working, what's the percent or the number that they don't work? So I did one. So you got 0.015. Now I read that word both, all, and. I'm going to multiply them. I punched that in earlier. Okay. So here's my workaround how I'm going to use that for B, just to show you another way to do it. So at least one system functions satisfactorily. So that could be one functions great, the other doesn't, they both, I could add them, do a lot of work. Or really, if this is the probability they both fail, I just need the complement that at least one of them works. So I'm just going to do 1 minus that. And make my life easy. 0.9998. Again, you could have done like one or more and added them together and done some work, but I saw that, I'm like, I'm just going to work smarter and harder on that one. Hey, should we do some final exam review questions too?
Dude, I would love that so much.
No.
I love the enthusiasm.